Welcome back everyone to Data Science for Everyone. Today we're going to be talking about grouped summaries. So let's just kind of get off with everything. So first off, we need to make sure to library import the NYC flights 2013 database, and then we also want the to import the tidyverse. So let's just get right to it. Okay, so we can use Summaries. Now here's the thing. The best part is that if you are British English, you can use the SE, or if you are interested in using just the Americanized version, you can use the Z. So let's go off with start creating a new delay function. So we can do mean, and we want departure delay, and then na.rm is equal to true. So make sure and always remember to remove true or remove NAs whenever possible, and we'll come back to it in just in a little bit. Okay. So that's great. That's how we can do basic summary functions. Now it's not terribly useful unless we actually pair it with group by. Okay, so with group by, this is allow us to change the unit of analysis on the complete data set. So we can do this by individuals. Okay, and we can also do it with within multiple groups. So we can do it by, for example, if we have countries, for example, we can do country year pairings. We can do continent year pairings, and we'll maybe get into some of those a little bit later on. But now let's do use our flights database to do by day. So let's do group by. We want our flights. We want year, month, day. Okay, so we're going to basically group by every single day. But again, because we do it by day, we need to also make sure to do month and day. Otherwise, it'll group every first of the month. It'll grab every second of the month, every third of the month, and it's not going to care about month or year. Okay, so we need to make sure that we actually keep that in there. So that's our group by. So now if we just take a look at this, okay, it doesn't actually look any different than anything because it's grouped by. We have to actually apply an action onto it, so an aggregate function of some sort. So now we can do summarize, and I'm just going to go on with the SE because that's what I'm familiar with. So we do by day, and then we want our delay, okay, to equal the mean, and then we want our departure delay. na.rm is going to equal true. And now notice here, okay, it is going to be regrouping our output, okay, by the year, month, day, and this is going to be basically overriding everything. So don't worry about this, but now notice our output, instead of a single number, okay, for everything, now we have it by the first of the month, okay, in January, then the second, then the third, then the fourth, then the fifth, then the sixth, then the seventh, and all the way through, okay? So together, when we use group by and we use the summarize function, they provide tools that are probably the most commonly used with our group by functions for using dplyr, okay? Now, before we go any further, let's introduce some that we've talked about this a little bit before about the piping operator. And so let's start looking like this. So let's maybe explore the relationship between the distance and the average delay for each of the locations. So first let's do this without using the pipe operator, okay? First time is without. So let me put a note here, without pipe, okay? So we have our by destination, and we want to do group by. We do flights data set, and we want our destination, and then we want our delay. Okay, so we're going to summarize, and we want by destination, and then we want our count to equal in. So in here, this function, we haven't really seen it before. In is just the shorthand version for count. And then we want the distance, and we want the average distance. Okay, so distance, and then nm rm is true, and then let's do delay, and then we do mean arrival delay, and then we want na.rm is true. And you know what, I want to make sure that we know that this is the average arrival delay. So most of the time you need to make sure that when you're creating variables, okay, that you give them something that's very, very meaningful. Because again, if we just do this summarize function, yes, we know that it's the mean, but whenever we're wanting to output data to someone, we need to make sure and giving a meaningful name. Okay, so now let's run this. All right, so now let's take a look at the delay. So notice now we actually have our destination, our count, our average distance, our average arrival delay. Now we also want to add in something a little bit more here. So we have our delay, but let's say that we actually want to filter this out. We want our delay, and then we want to make sure that the count has to be greater than 20, and our destination cannot be equal to HNA. All right, so now let's take a look at it. Okay, so now, again, this doesn't change much to this particular view, but if you look down here, okay, the number of rows that we have is significantly smaller. So now let's create a plot with this. Okay, so we're going all the way back to when we were using Ggplot. So let's do Ggplot, and we want data is equal to our delay, our mapping. Whoops. Oh, all right, hold on, let me clear that out. I was hasty. All right, so we want our mapping and our aesthetics to be x is equal to our distance, y is going to be equal to, we want our average distance. Average distance, and then we want our average arrival delay. Now remember, when we're adding in items, okay, for Ggplot, we want to use the plus sign. All right, and so then we're going to have geom point, and then we want our aesthetics to size is going to be our count. Okay, and then we're going to add in some alpha. Now alpha is going to be basically the transparency, and then we're going to do geom smooth, and we want to get rid of our standard error. Okay, and let it run for just a second. And this may take, again, depending on your machine, this may take a bit of a minute. And I'll speed this process up just a bit. All right, so here is our plot. Now, what we've actually done in this, okay, so again, here we have our average distance, we have our delay, and notice now that the count is based on the sizes. And now you can see actually here with how large these count numbers are, why we actually got rid of those that where their counts are less than 20. We need to really make our data set a little bit smaller. Now what we've actually done, okay, we followed 3 basic steps, okay. Okay, to prepare the data. Let me actually say 3 preparation steps. So the first one was the group function. So first we group by, and we did this, we grouped the flights and the destination. Now the second thing that we did was we summarized the data, okay, or we aggregated. All right, and then finally we had this third portion here as we filtered the data. And again, we filtered this by removing the Honolulu airport, okay, which again is it's much further away as any of the next airports, so we just wanted to grab it, get rid of it, so that we can have a better looking curve. Now, this was a lot of steps, and it can be a little bit frustrating to write out all the code. So now let's start using the pipe operator, and we'll recreate the same piece of code. Okay, so now we're going to be using the pipe operator. Now remember, the pipe operator is this. Okay, now for those of you that are typing this out, this can be a little bit of a hassle. You can hit Command Shift M or Control Shift M, and it will automatically import it for you. So let's get this started. Now, first off, we want to create delays. Okay, that's going to be our new name. We want the flights data set, the pipe operator, and then we can group by, and then we want by the destination, add a pipe operator, and then summarize. All right, and then we have our same function here. So count is equal to n. Whoops. Okay. And then we want we're just going to do distance now. Mean, distance, and then we remove the missing values, and then we want our delay to equal the mean of the arrival delay. We want to remove the NA values, and then we add in another pipe operator. Okay, and then we're going to add in filter. And then again, we do count is greater than 20. Our destination is not equal to Honolulu National Airport. And so that now gives us the same data set we had before. Now, the reason that we do this, and let me maybe just kind of take a second to explain the mechanics behind this. So let me clear this. And if we did something like, let's do group by. Notice when we take a look at this data, it requires the data and then some other variables. Okay, so let me actually put in a question mark here, and we can actually look at the this side over here. So we have group by, and it takes in arguments. Okay, so it takes in data, and it takes in any other types of arguments we have: adds, false, drop, etc. Now this dot dot dot, okay, actually is about any variables that we're going to be wanting to group by, and again, we can also ungroup by them later on. So what this pipe operator does, so if we do flights pipe group by, all right, what we wind up actually having here is that the pipe operator takes flights and pushes it into that first slot that we have. Okay, so then all we have to do is do destination, and it will automatically group by the destination. So that is very, very useful to us because it kind of expedites the process. Okay, we don't have to keep writing flights inside here over and over again, and it takes this next group and then disperses it into the summarize function. Okay, so it's taking here, remember we created a variable with this piece, and then we had to create another variable. Well, what it does is it takes this, puts it inside of group by, and then it takes the group by and flights and pushes it inside to the summarize function. Okay, and we could have kept doing this all the way through, even with our data visualization. Okay, so it is just it also helps you focus on transformations and not what's being transformed. Okay, so again, one way you can think about this is taking this pipe operator and using it as the word then. So flights, then group by destination, then summarize. Okay, so this is great. Now we do have a little bit of an exception, and remember, whenever we are, let me pull up really quickly. When we are using any type of Ggplot plotting function, remember that instead we cannot use the pipe operator, we use the plus sign. Okay, so if you're going directly into a plotting function, just remember when you're inside of that ggplot, you need to use the plus sign instead of the pipe operator or the then operator. So now let's talk about using group by and missing values. So again, you may have been thinking about why we keep talking about this na.rm. And this is, again, what happens if we don't set it, okay? Now, if you remember from a couple lectures back, we talked about that NAs are contagious. So if we do flights and we do group by and we want year, month, day, and then we're going to do summarize, we want the mean, let's say average is equal to the mean departure delay, and we are not, notice here, we will not put in the na.rm. Notice what happens here. Whoa, we got a lot of missing values, okay? And that is because that NA is contagious, okay? Anytime we're trying to do any type of arithmetic with it, it's just going to kind of take over. So let's rerun this with the na.rm is equal to true, and now run. Now look, okay, we actually have our averages in there, our means in there, and it didn't cause any problem. So in the case where maybe, let's talk about we're missing values or talking about canceled flights, okay? So let's talk about find all not canceled. So we take our flights and we want to filter this. That's not is NA. So remember this not, okay, I say it as not. This exclamation point is negating this is NA. So we want departure delay and not is NA arrival delay. Okay, so this gives us not canceled. So these are all of those items that are not canceled, and we're going to save this and we're going to use it in a couple examples, so make sure that you go in and do this. So this next one, so let's do not canceled, and let's do group by, and we want year, month, day, and we're going to summarize, and let's say that we want the average of the departure delay. Now notice here, since we've already taken care of the removal of the NAs, we shouldn't have a problem now whenever we're running this. Okay, so notice here we have year, month, day, average, and there's not a problem. So let's talk about using the counts method. Okay, so we're going to be talking about counts. Now, whenever you do any aggregation, again, please, this also does include, okay, counts. Okay, it is an aggregate regardless of what we want to talk about. It is best to look at removing NAs. So one way that we can also think about this is the count. That's that in function. All right. It's also could be something like sum is not is NA. Okay, this could be basically done in a similar way. So let's try this. Delays is not canceled, and we want to group by this time, and we want the tail number. And we're going to summarize, and we want our delay to equal the average arrival delay. So now let's do ggplot, and we want our data to equal delays, our mapping. Again, I'm typing this out a little bit the long way, using data mapping just to remind you guys about what is actually being typed out. You do not have to put these mapping is equal to, the data is equal to, but it does assist with reading, so I would highly suggest you keep doing that, particularly if you're going to have to pass this off to someone else on a group project. So we're going to do a frequency plot. All right, and let's do our bin width. Let's say 10. Plots. So notice now there are some planes that have an average delay of, well, let's say 1500. Okay, so that's going to be almost 5 hours. Okay, that's problematic. Okay, notice they're all the way out here too. All right, this is our delay, and so that's crazy. Okay, so now maybe there's something actually a little bit different that we're not noticing in here, so it's nuanced. So maybe let's draw a scatter plot of the number of flights versus the average delay. Okay, because yeah, something is going on here. Notice again, there's not a lot that are in, they're very, very small delays, but we do have some that are way out here for these large delays. So, okay, so delays, and it's going to be not canceled, and we want group by, we're going to use the tail number, and then we're going to summarize, and we want delay equal to the mean of the arrival delay. We're going to remove the NAs, and then we're going to have N equal to that. We're going to run it, and then we're going to do Ggplot. We want data is equal to our delays. We want our mapping to equal AES. X is going to be equal to N. Y is equal to delay, and then we're going to do geom point, and then our alpha is going to be equal to 1/10. Okay, so that took a little bit of time, but notice now that we see the reason that we put in this alpha, okay, just get this 1/10, is so that we can actually see something that's going on here. So notice there's a ton of values down here, and then it gets lighter, so we can see these nice trends in here. So it is not surprising, okay, that there's a lot of variation in the average delay when there are a few flights. Now, the shape of this is very characteristic of when we plotted the mean versus the group by, and we'll see that this variation decreases with the sample size. So let's take a look at that. Let's do our delays. Okay, and let's filter so that we want n greater than, let's say, 25. And so now here, let's actually use Ggplot with the pipe operator. Notice now we can just put in mapping. And so we want our aesthetics. X is equal to N, Y is equal to delay. And then we want geom point, and then we'll have an alpha again set to 1/10. And let's give that a second here. All right, so now we can actually see that this is a very common pattern. All right, so we also notice that, again, smaller sample size changes everything just a little bit. So I want you guys to go on and play with this as much as you can, and maybe try this out with a couple different data sets. And let's actually end this here, and I hope to see you guys next time. Bye.